Hello and welcome you all to the session today, to the webinar today, where we are going to discuss about the critical linkages between manufacturing optimization and supply chain planning. Today, our webinar is on redefining manufacturing excellence and customer satisfaction with Logility solution. I have today Anirudh Srivastava from Logility. And before I introduce him, let me give a background of myself and the company that I represent. I am Sheetal. I take care of operations here in Anamind. Have been part of this organization for about 8 years, taking part in various supply chain implementations across different companies and industry, and excited to be part of this webinar. This webinar is recorded for all the users, and we would send across the recording of the webinar post the session. We would also take up the question and answers at the end of the webinar. If you have any questions, please feel free to use the Q&A section provided, and we would be happy to answer them. In case the questions are not answered, we would, during the webinar, we would take them up separately and we'll send across the details over email. But we would be very happy to see questions coming in from as many of you as we have. So to start off with the webinar, we have Anirudh Srivastava from Logility. He's a part of Logility for about a year now. He's a principal business consultant in Logility, has about 2 decades of experience in aerospace, food and beverage, and automotive, industry, in primarily in planning, inventory, and optimization roles. So happy to have him here on the session today to where he can share his insight and show us how there is a critical linkage between manufacturing optimization and supply chain planning. We will see how we can model business rules and process constraint to optimize the production, scheduling, sequencing, and streamlining the entire operation to improve the order fulfillment. So happy to get started. Anirudh, over to you from here.
Thank you, Sheetal. Thank you for the generous introduction. I'll try and give a brief about Logility very quickly. So we are one of the leading solution providers of end-to-end supply chain planning applications. Our presence is primarily in the US, followed by Europe, and then Asia Pacific, which practice we just recently started. So I head the consulting practice along with the sales team, which is headed by Arvind. We also have an expanding team right now. Chinmay has joined our team as the direct sales, so he will be reaching out to you guys to connect and see how we can make and add value to your business. For me, Sheetal's already introduced, so nothing more from my end. Let me just give some context to the discussion. So being an end-to-end solution provider, often we talk about demand, we talk about inventory, we talk about supply. And within supply, we sometimes do not end up discussing the importance of manufacturing to the extent that it needs to be, given that manufacturing is a key cog for folks who assemble or manufacture or produce what needs to be supplied and to who it needs to be supplied and when it needs to be supplied. And given that manufacturing has a significant cost that goes into making a product, it is imperative to model the manufacturing cost within a supply chain to truly understand whether you are able to deliver the value proposition to your customer and to the business that you are working with. So given that context, let me put the agenda out today and how this is laid out. So we'll talk about the context of manufacturing within business, give a quick overview of session via demo. The order sequencing rules will be shown via a short demo. The due date quoting feature within manufacturing optimization will also be demonstrated by demo. And then we'll have a slightly larger demo or a longish demo for scenario modeling, which would be talking about the what ifs and how you would model your real-time practical decisions into the day-to-day reality of making your business objectives and your customer satisfaction goals in line with what your business is. So, and then we'll talk about what are the key takeaways and the industry value add that this solution will offer to you should you end up adopting something like this, and why it makes a difference and how it makes a difference. So we have some quizzes in between, which will give us a view of what you do and how you do if you do manufacturing optimization. Some videos, and then we'll have a live Q&A. Please feel to ask as many questions as you want. I'll try and answer them within the time frame. If not, we'll take those questions and we'll come back to you in a written response at some point in time after the webinar. Okay. So manufacturing is a unique capability within the supply chain, and it has its challenges because today, with the proliferation of products that one has to make in the different combinations that one has to make, it only adds to the manufacturing complexity. Why we do it is because customers are demanding more and more variation. They're demanding lesser quantities and higher customization to what they want and how they want things to be. So that's creating a complexity which is trickles down to your manufacturing base, where you have to make smaller lots in more varieties and align with what the customer wants in a more and more diversified and piecemeal fashion than a mass production fashion. Then, as you all know, demand or supply or your capability in terms of capacity, these are all changing variables. None of these end up being firm in time, forget within a month, but even within a week, your demand can fluctuate, your supply can fluctuate, and so could your capacity, installed capacity. Should there be a breakdown or should there be a disruption which makes one area of your facility or your multiple facilities non-functional? If that is the case, then you have a direct impact on your revenue, right? So you need to have your demand, supply, and your capacity fluctuations considered in order to be able to deliver the revenues which your business expects you to deliver in the market that you operate in. And then there's one way is, if something has happened, I'm going to react casually and I'm going to make a quick decision and I'm going to implement it and see what happens. But the more proactive way is to understand, if I was to do option A versus option B versus option C, what are the implications in terms of cost, revenue, and inventory if I was to be able to deliver between the different options that I've come up with, depending on the situation on hand. And that has a direct impact on your cost, right? And then from a manufacturing perspective, if you have a very high capital intensive business, then the utilization or the time that these machines are deployed in value added manufacturing makes a huge difference to you. At the same time, you want to make sure that your output and your throughput is lined with your sales revenues, and you're no longer delaying your sales or losing sales because you're not able to make what the customer needs and when they need and how much they need. This directly impacts your profit margins, because a lot of your cost, apart from distribution and your competition discounting that comes into play, your manufacturing activities will majorly impact your profit margin. So given these business challenges and this business impact, manufacturing optimization assumes a significant place in where you can sequence your jobs or your work orders or your production orders, both to deliver customer satisfaction, but also to increase the profitability and revenue streams for your customers. These are some of the customer success stories that I would just wanted to quickly highlight. We have more, but I just picked a sample of 5 from different industries. Some of these names you may not be familiar with, but if you need more information about who they are and what they do, we'll be happy to share this with you. As you can see across the board, across different industry verticals, from food to paints to bottling, we have been able to deliver not only improvement in service levels and fill rates by deploying the solution, but also reduce the cost of procurement, inventory carrying costs, transportation costs, and inventory turns. At the same time, also manage to balance your manufacturing capacity with your product priorities, replacing your Excel-based work processes with more automated workflows, which make sense and are connected with each other. Spoilage and obsolescence, optimizing your sequencing and scheduling to deliver the maximum bang for your buck. And again, towards the end, as you can see, inventory obsolescence, spoilage, all these things are parameters of your business that you can influence when you deploy manufacturing optimization, along with obviously the entire suite. But manufacturing optimization has a number of parameters and performance which it can influence. Let's get into a quick poll mode before we demo a basic view of what this solution does. Sheetal, over to you. This poll is about how you determine the timing and quantity of the production orders.
Right.
Sheetal, you'll have to read out. I am not able to see.
Okay.
Yep.
Yes.
Yeah.
So the poll result, basically we have maximum voting on enterprise resource planning and the option which is advanced planning and scheduling. So that's the result that we have.
So I think that's great. If you're outside of your Excels and your rules of thumb, and you're already in an ERP system which generates your quantity and timing of production orders, I think that's great, because that's the baseline to which you want to be. And then on top of it, if some of you are already using planning and scheduling systems, not sure which ones you're using, how you're using, but if you're already using them and they're adding value to you, great. If not, then go ahead and take a look at what we have to offer. So let's put the context of why manufacturing optimization within a supply chain, right? So this is a block diagram in which what you typically have is, let me switch to quick slide on where, if you were wondering, where exactly in my entire technology landscape and application and processes which we have, where does manufacturing optimization fit in and how does it fit in, right? So let's say you have a demand planning system from which the demand forecast comes for replenishment planning, and you already set the inventory. So I'm assuming inventory is already determined. That creates your requirements for replenishment planning for the master scheduling. So this is a gross aggregate level master schedule plan, production schedule. From that, step number 2 would be you transfer the master production schedule into your manufacturing optimization schedule. That will create a feasible production order schedule with due dates, which can be sent back to replenishment planning. From replenishment planning, you push out the production of feasible production plan orders into your ERP system. The ERP module has an MRP within itself and also may have, in some cases, a production planning module within itself. That module will then create the production orders and release it to what you call a manufacturing execution system on the shop floor for execution. Once the orders are released on the shop floor for execution, there would be an exchange of the scheduled work orders between the manufacturing optimization and the manufacturing execution system. You can transfer the status and the production status of what is happening of plan versus actual. Based on any changes that come up and any production updates, you can send them back to MRP, or you could alternately also choose to send them directly from the manufacturing execution system back into the manufacturing optimization system, which would then give you a picture of plan versus actual, and you could compare your performance versus what was planned on a particular day, a week, or a month, and what was actually made and delivered on that particular day, week, and month. So just a rough um, process flow of where information would flow into what systems and what outputs would flow and what connections you would make if you were interested in finding out some more. So what does optimization do? Typically, it will, as you can see, you have routings and you have Gantt charts. If you have if your capacity is already overloaded, then it will either attempt to pre-build some quantity, or it will tend to move some quantity if your capacity is exceeded and move it to another alternative routing which you can use to schedule a particular job. If you have multiple operations which are dependent and they're dependent on each other, for example, operation A, B, and C are in sequence of each other, operation 1, 2, and 3 will be sequenced in a manner when operation 1 finishes operation 2 finishes operation 3, or they can be done in parallel, right? And these can be done for multiple products, product 1, product 2, product 3, and you can have different sequencing done based on a multi-step operation. Also, a sequencing between the products. So for example, you have a work center and a machine, and you have a particular routing on which a product's being made. The different products will have a different sequence based on what priority you've set for the products. And this priority could be set along multiple dimensions. We'll talk about more of that. But let's say you have set up order due dates to when it's delivered to the customer. Product 1 is first, followed by product 2, and then by product 3. And the same rules can apply across the same routing or across multiple routings, across machines and work centers. And then the good part is that manufacturing optimization creates a feasible production schedule. That means it constrains and considers the availability of materials. For example, if raw material 1, 2, and 3 are required to make product 1, until raw material 1 is available, product 1 cannot be scheduled to be delivered and be manufactured. All 3 have to be made available in the quantity that it's needed. Only then can the job be scheduled and completed. So you can have these as soft constraints. If the material is not critical, you also have them as hard constraints. This tool will show you in different colors whether a hard constraint is being violated. It is not going to schedule, but if it's soft constraint, it's going to schedule it, but give you a different color indication so that you can go make those changes. So this is what manufacturing optimization does in a nutshell for you. You would be interested in knowing that if it's really modeling all the constraints, this is a list of the different parameters that can be set inside the tool to order to create these feasible production plans. You can have single or multi-step routings. You can have work centers, machines, machine lines, alternative routings. You could set up lot size constraints between one step of the operation to the other step of the operation, between one machine line to the other. You can have multiple shifts, 1, 2, and 3. You could have maintenance shifts, holidays, tooling, labor chips, raw material availability, shelf life can be put in. And then you have the more advanced stuff, which where you can set up your changeover logic. If you have different grades or different um, type of material of jobs that need to be sequenced, then you can have rules which you can set up for if I have to switch from product A to product B to product C. This is the matrix of sequence dependent changeovers and transitions. And then you can set a logic saying, if on a same work center and machine, product A and product B have to be scheduled, and I'm making a switch, you can write scripts and set those up for the system to understand that there is a change and there's a shift. I would now need to compute and optimize my changeover pattern based on these quantities of times that take to do it. You could also do it on cost, where you can set the cost of these transitions and changes, and then you can optimize based on cost as well. And then you have something called as scalar keys, which are also flexible attributes. An example in the example which you'll see is something called as paint. So if paint is an attribute on which a changeover happens, or any other attribute which you think is important for you to decide, those can be added as scalar keys in addition to the existing parameters which are available on your manufacturing and your production work orders. So that takes us to the demo. Sheetal, over to you. If we can have a quick demo of the overview of manufacturing optimization.
Sure.
Of the interface that you are able to see when you log into manufacturing optimization. What you see is there are two halves to the screen. The top half is what is showing you the Gantt chart. The Gantt chart on the y-axis is machines, as you can see listed. And on the x-axis, you have the different activities or orders which are scheduled along the time axis. So this is the time dimension. And this is where the listing of all the machine happens. Once we get to the bottom part of the screen, what you're seeing is different tabs. Each tab has its own set of information that it displays, which can be used for you to evaluate how the production planning and sequencing algorithm or these rules that you've selected are performing. So multiple options that you have for view are audit scheduler, statistics, the inventory usage, the details, tooling and labor detail, and so on and so forth. You can also select your workspace. Currently, the default is set to having all tabs being shown to you, but you can also select a limited view of what you would like to see. For example, you can say it's only going to show you a Gantt chart along with the operation scheduler. Now, the different menu options which you have, capacity is where you define all the constraints under which your production planning and sequencing algorithm operation has to perform. Product gives details about the make and buy items and the bill of material. Process gives information about routings and machines on which a different sequence of activities will be executed, along with certain rules and codes and equations and matrices for your changeover and setup times. Demand is where your work orders are set, filters are set, and due date quoting on your orders is done. Reports is where standard reports can, once your schedule is created and published and you're happy with it, then you can show your reports and publish these reports to all your stakeholders.
Digital. I'm going to share my screen again. So that was about manufacturing optimization, a quick glance through what it has to offer. Once you know the basics, now what's important is I have a certain set of orders into the system. I have my machines, I've defined the constraints, I have my labor shifts, my material availability, my inventory of raw materials. All that information is set. Now I would like to evaluate what is the best sequence in which I need to make my orders so that my end objective is fulfilled. Before we go there, let's do a quick poll. Sheetal, over to you. If you could just run that poll about how you determine your optimal sequence of production work orders to execute.
Yes, so I have published the poll. The second poll, as Anirudh mentioned, sure.
Looked at the graphical user interface, it's time that we now understand how we can run different sequencing algorithms and then compare them for their performance on key performance indicators. So we go to generate schedule. As you can see, we have to select an order filter. These are predefined order filters. And you have to select schedule settings. The combination of an order filter and schedule setting is going to give you a desired algorithm that you want to run on a subset of your work orders. So we have chosen firm production orders and priority due sequence. Let's run the schedule. Once the schedule has run, you have to now look at what exactly is happening in terms of the performance. You can click on the order statistics tab set and it will tell you the number of jobs which are scheduled, orders scheduled, and then the overall performance being a total setup time of 0.41 days, which is a significant portion of the 3 days worth of work orders that we've scheduled. If you want to get into more details in terms of where exactly the setup time is coming, we can switch the utilization menu and look at machines, change the grid view. You can see the different machines are listed along with the statistics. Now here you can see that the paint line has a setup time of 588 minutes. What if you were to sequence this differently to minimize this changeover? That's the next question that we want to have the solution answer for us. So we go back here, we select the same firm production orders, but we select a different schedule setting of changeover optimization. We run the generate schedule option here, wait for the data to be processed in a couple of seconds. And now we go back again into the order statistics view. Same number of jobs scheduled, but then when you look at the average duration, which has come down to 0.17 days, and the total setup time has significantly come down to 0.16 days. Again, looking at where exactly has this reduction come along, you can change the grid view and you go down and you can see that the total setup time on the paint line has come down to 228 minutes.
Okay. So the next thing would be I have a feasible production schedule, which I like. Let me publish that schedule and then start to commit to my stakeholders within the larger supply chain as to when those dates, what are the dates on which the material can be delivered, right? So there is one is via MRP, you'll get the quantity that you need at a master production schedule level, but then the feasibility check about when can you do it and is it actually doable or not, well, it's going to come from manufacturing optimization. And this is where the due date quoting feature inside manufacturing optimization is a great tool for you to communicate to all stakeholders, to keep them informed, and to be able to commit orders when your finance teams want them to be delivered in a sales team. It adds a lot more credibility and visibility into the process. So time for another poll. How does your organization currently quote and promise production order due dates? Sheetal, over to you.
We have, so I've published, basically opened the poll, the third poll. How does your organization quote and promise production order due dates for order fulfillment? The first option is no mechanism in place to do so. Rules of thumb on average. The third option is where we are getting some vote, which is basic MRP solver. I'm not reading out the whole line, but I hope you're seeing that on screen and you're able to vote on it. We'll give a couple of seconds more to answer the poll, and then we'll publish the result. So yes, I'll now stop the poll and publish the result. So we have got equal number of votes, say for example, in rules of thumb based on average lead time and then basic MRP solvers without any production constraints. So these are the two options where we have the maximum.
Okay,
uh,
good. I think that's expected. Um, a lot of times, the ability of an organization to quote when will I deliver your order is dependent on so many processes that when it comes for the customer care team to come back and say when will my order be delivered, unless your systems are integrated from sales to demand to inventory to replenishment to manufacturing, there's very little ability for you to realistically quote a due date. And that becomes a very quick customer dissatisfaction in case you quote more and deliver early also, and in case you quote less and you deliver late, right? So both of those things are not acceptable when it comes to customers today. Okay, interesting. Shita, let's do a quick demo. I'm going to stop sharing the screen as to how we are able to do due date quoting and how that feature can be utilized to more accurately promise due dates.
Sure, I'll play the video number 3 that we have.
Happy with the changeover optimization algorithm, which gives you better performance in terms of your changeover setup times and improves your manufacturing costs and efficiency. You now want to look at how I can use this information to better commit and code orders to my customers. How you can do that is you could go into the order scheduler tab set. You could run a filter for a specific work order. You can type the name of your work order here and filter it. It will take you down to that particular order information. And as you can see, different columns have all the information it's given. The end date for a particular order is what's the feasible plan by which the order can be delivered, completed, and delivered to the end customer. Another way to do the same thing would be to go into your order due date tab set under process, right? Under your work on your homepage. You could enter the order name. You select the particular item for which you would like to do it, give it an expected due date where when it should expect it, the quantity, and then you go back and select a particular routing for it. As you can see here, you can go select a particular routing. You check the routing, you select the routing, and you can hit add order. Then you can see the particular work order along with the due date on the production routing on which it is being created. And one last quick way of showing that more information would be you go to reports, you do order dispatch reports, and here you could select the different classes. Let's say you select these, you select the priority codes, and you select the date when you want this to be done since we are in the month of January. So let's just take it for the first 6 days of January. And you start from there and you apply and you get all the different order dispatch report along with the work order number, the routing and the start and end dates, and you can share this information with your stakeholders.
Thank you, Sheetal. I'm going to take the screen right back and we will move to the next capability, which I'm going to come back to this, is now that you have a plan, you're executing a plan, but nothing goes according to plan, right? You had planned something, something else came up. I was expected to make something on a certain day in a certain quantity. Either my machine's not available or my material didn't show up on time. And now I have to react to this and understand what will be the impact and what can I do to either move the order up and be able to deliver on time or commit back to the customer and the client that I will not be able to do this, and this is the next day by which we should be able to do this. So now getting into scenario modeling. Before we get into that, quick poll number 4 on scenario modeling. Sheetal, over to you.
Yes, so I am publishing the poll, which is how does your organization model scenarios and perform daily analysis for feasible production alternatives? Is there no formal mechanism in place? Do you use MS Excel, Power BI for modeling decision alternatives? Or is it basic MPS scenarios and analysis at aggregate level? Or is it advanced simulation and analytics using APS? And the very last option as well. So let's see, we have people voting. We'll give couple of seconds for the users to or the attendees to vote, and then we will close the poll. So I would request everyone to select so we get an idea of how it is, how are the scenarios being modeled in your organization. Okay. All right. I'll just stop the poll and basically, Anirudh, we have maximum poll in MS Excel and Power BI for modeling decision alternatives. So that's what we
Okay.
have.
Okay. Yeah, that's also typical. Thanks, Sheetal, for sharing. So while MS Excel and Power BI are great tools, unfortunately, the latency by which the data is transferred and the ability of Excel and Power BI to consider the dynamics of how a manufacturing system operates, right? With so many constraints and so many variables that it's virtually impossible for someone to make a decision at an order level or a product level without having to just look at something at a very aggregate level. So people, you may end up looking at something at a very aggregate level, but when it comes to looking at things at a detail level with hundreds and thousands of constraints and variables in place, then these tools are limited in their ability to do so. So, Sheetal, over to you. Let's run a quick demo of how we can do this inside the production planning and scheduling system called manufacturing optimization.
Sure.
Imagine that you run your schedule and it gives you certain indicators and is asking you to make certain decisions in terms of material availability, labor shifts, machine capacities, and so on and so forth. So, how would you evaluate the different parameters that have been set and can be configured to give you different outcomes and choices that would reflect the business reality? So, let's look at some of the ways to make these scenarios more practical for your consideration. So, I have run the schedule. This is changeover optimization. I can see different colors. The yellow color over here indicates setup times. As you can see, there's a light green indicator on the final assembly line. If I click on that, it pops something up and says for product 34, there is an inventory shortage for accessory number 3, right? So when I go back and look at this, I can go into the logs, and under the logs, we can see that for product 34, there's an error message or a warning that comes through, and it says there is a shortage of material of inventory for this particular raw material item called accessory 3, which is required to make this final assembly. Going back to our workspaces, we can also look at the inventory usage tab and select the accessory 3 to see what is exactly is happening with this particular accessory or a component which is being used for the final assembly. As you can see, right when the final assembly to process step here, the inventory declines and goes into red. Now, red color indicates that you don't have this material in stock. You could check the details. This is where the inventory is pegged against the order, and you can see day by day or order by order consumption of this inventory against the work orders. Under here, once I select accessory 3, as you can see, it gives a listing of the different work orders. It also gives you the consumption quantity which is being consumed and what is the end quantity. If I scroll down here and look at when exactly does the inventory become negative, right here, as you can see, product 34 on 5th of January becomes negative because it's no longer available in stock and the quantity consumed is for the order is much higher than what's available in stock. So how do we resolve something like this? Currently, the job has been scheduled, but it's been given this light greenish color because accessory 3 is not a critical constraint. It's a soft constraint. It's not a hard constraint. So let's see how I can change something like this. Going back to product, we select this item here. Go and select accessory 3, and we edit accessory 3. As you can see, these are the different settings for accessory 3. We make this is critical, yes. We save it. We come back to the workspaces. And to see its impact, we will again generate a schedule with firm production orders and changeover optimization to see its impact on what is happening. So as you can see, as you go to the final assembly line, you can see this order is now delayed. It's a red indicator. As you can see, it is saying that this order is now late. Let's run another scenario where you want to evaluate how you would be able to execute this particular late order, which is highlighted here. And you would like to make sure that this is no longer late and what options are available to us. As you can see in this particular order, when you look at the inventory usage, the inventory doesn't become negative. And that means it's not that there was not enough stock to make this. Once you made it a hard constraint, it's just that the equipment is not available or the machine on final assembly is not available as highlighted by the gray marker. And since it's not available, the due date is being pushed out. So what can we do to remedy this? One of the things that we can do to remedy this is go to my final assembly operation. I can see that there are different shifts which I've set, five days, 16 hours each, 6 days, 16 hours each. Currently, the one in effect is 5 days, 16 hours. So let me switch this and make this on the 2nd of January 2023. I bring this into effect. We update this. And then going back to our workspaces, generate the schedule from production orders, change of optimization, and let the schedule run. So what is the outcome? As you can see, the job that was originally late has been moved up because the machine has now been made available for another day. And that's why this job is no longer late.
Why does MO make sense for you, right? Why does manufacturing optimization add value to your business? So no matter what you do, how you do, somebody is always going to know why and how this is going to add value to me, right? So moving this to the next slide. Um, at a very high level, as you can see, the tool is not only powerful in the sense it can compute multiple work orders in a short amount of time span using different sequencing rules. It's also very easy to use and an easy to navigate interface, right? So it is not as if there's rocket science happening behind. You're able to quickly navigate between different options and you're able to use the different rules, sequence them, see the output in a very visible manner, and be able to explain what is happening in the system. Second thing is it generates plans which are accurate. When I say accurate, it's more feasible because those plans have been generated. The order due dates, start and end dates have been generated using multiple capacity and resource constraints which are already modeled into the application. So you don't have to worry about theoretical plans. This is an actual plan which can be executed, and it will hold true as long as the conditions and constraints you've defined are holding true. And then because it has the ability to model the customer demand and sequence and resequence using multiple rules of priority, changeovers, um, order codes, order priorities, so many different rules, processing times, and also consider cost, right? To do so, it can give you a matrix in which you can evaluate what is the benefit to my customer if I use this algorithm versus this, and what is the cost at which it's going to happen. So you have a ready-made matrix of cost versus service trade-off, and you can decide which one is the best option for you. All these three coupled give us an advantage and an edge in the industry, where these solvers, which are inbuilt, are advanced operations research solvers based on science and based on technology to support that science. You can run multiple scenarios and save them, and you can compare these scenarios in terms of the outcomes of these scenarios across multiple performance indicators in terms of utilization, throughput, cost, and so on and so forth, right? So to summarize the key benefits, if you have a solution like this, then you have visibility across the board and across multiple plants. So you have a centralized visibility for planning and scheduling. That centralization gives you cost efficiency and also asset productivity, because you know what's happening inside each plant, and you're also aware of the linkages between the movement of material between the different plants. If you need to switch something, change something, you don't have to rely on a phone call or an email to a particular plant that is not aware of the bigger picture. You can respond quickly, and you can keep that knowledge of what you did and how you did it as a central team, rather than having it as a individual team lying in some part of the country, which is only concerned about their own plant productivity and efficiency rather than the entire big picture. Optimal utilization and throughput. Because you have the constraints modeled in real time, you have the ability to track the performance of your work orders inside your factories using actual data, which is plan versus actual. It gives you metrics on plant utilization. It gives you metrics on what you've made and which day you've made and how much you've made. That allows you to ensure maximum utilization of your capital investment. So it allows you to give better customer service and fulfillment, right? Because you optimized your capacity and your delivery process, you're also be able to enhance your customer service. And then because you have all these levers available to you in one place where you're able to see the real situation of what's happening, often when you have to expedite stuff because an order is delayed or order is not, instead of reacting at the last moment where you may have to use more expensive means of firefighting and expediting, you have upfront visibility and you have the ability to react in time, because the system will flag you and tell you upfront what's feasible and what's not feasible. Then, like I mentioned at the beginning, manufacturing is a part of supply planning. Within the larger picture of supply planning, multiple facilities and the incoming raw material planning, which is used to plan your entire supply, the material supply will be pegged against your multi-step production routings. That means what is being made, when it is being made, is conditioned on the availability of inventory, and what is consumed, when it is consumed, is also visible to you. If a new work order comes in, routings and sequences are defined. Whatever rule and whatever routing you choose, you can just process it and will select the routing on which it needs to manufacture because of the rules that you've set in, availability of machines, and the sequence of steps which you have to make. And then lastly, it's not just an isolation that I have capacity today, so I can just go ahead and make it. It's going to check whether you have the machine available, whether the labor is available, whether the material is available. And so it aligns your MRP planning with your supply planning, with your manufacturing planning. So that's the huge benefit, where all things are aligned. And then instead of giving a customer unconstrained production schedule, which means, well, I don't have the capacity yet, I'm going to schedule and I'm going to come back and tell you what I can do for you. That doesn't work in real life. once you respect the constraints, you can give a feasible delivery date and production date to your customers. You can compare different alternatives on a platform where you can compare your plan versus actual performance. So you can feed the data coming from a manufacturing execution system into this application where you can track plan versus actual, and you can have metrics to track what you're doing and how you're doing. And then if you have multiple plants across the nation, you can track all plants in one location, and you can track the movement of assemblies and sub-assemblies within each plant. Should plants have a dependence on each other, and you will be able to track it from the cradle to grave. That means from start to finish, you will be able to have visibility and traceability of when and how your product's being made. So key takeaways for you. You can model multiple production constraints across labor, machine capacity, tooling, bill of materials, routings, and work centers, not just across one plant, but across multiple plants. All this knowledge is centralized and it's available to you in one place. You can test, validate, run multiple sequencing rules. You can customize your own logic depending on the industry. If you're pharmaceutical, if you're food and beverages, if you have some unique scheduling rules and business priorities which you want to program and you can run, you have the ability to customize them and not just use standard rules. And you can build those rules and functions because there is a Python library available for you to do so. If you have to code to the customer when something will be available and how it's going to be available, you need to know when raw materials are available, coming in, when are they getting pegged, against what order are they getting pegged, how much quantity is left over, what is being allocated, and it has to happen across multiple steps in the process and across multiple plants. Unless you have true visibility of what's happening in real time, the ability to quote a date to a customer is severely compromised. And in the event that you have demand, supply, and capacity fluctuations and changes, you can run these what-if scenarios very, very quickly and resolve whatever in production scheduling infeasibility that this particular constraint is creating in order to move between hard and soft constraints, and then be able to understand the impact on your capacity, your utilization, your customer satisfaction, your manufacturing cost in one window and come back and respond to your customer. And you have the ability to generate standard reports and analytics, which can be used for decision making and tracking across multiple plants. So that brings us to the end of the session today. I hope, first of all, thank you for joining in. I hope this was useful to you and it gave you a glimpse of what we can do for you as a company and how you can go back and talk to your respective stakeholders and share with them this information of what we can do to improve your business and deliver the results that you want to deliver to your customers and your stakeholders. Thank you so much. We are open to questions now.
So we had, it was quite insightful in terms of looking at how Logility as a platform can optimize various constraints. It can take into account the material constraint, the labor constraint, the capacity constraint, all of that, and optimize the whole model and give a visibility to the entire supply chain team and also to the sales team who would be interested in knowing where exactly their sales order is, when exactly is it going to be fulfilled, so they can go and talk back to the customers and possibly speak and in advance let them know, hey, there could be possibility of a delay, or they can expedite and get that product delivered on time. So that's the beauty of this system, and something that if we have a tool like Logility in hand, it's easy to do all those scenario planning and see how we can optimize and you know improve our customer service level and customer satisfaction.
True,
So
Sheetal. Well said.
right. I would request attendees, if you have any questions, feel free to ask that. We have one question where, I think it's already answered in the presentation. Pretty much everything is covered, but um, you know, if we can look at an overall, utilization report user-wise, would Logility as a platform be able to provide that so that user has an access of looking at day-wise optimization or utilization of each of the resources?
The answer is yes. So you can have a work center wise, a machine wise, a machine line wise, a plant wise. Once the analytic is configured, then you can drill down at whatever level you want. So it could be a product machine combination, a product machine work order combination. You have the ability to navigate at whatever level you want. And the status of what is coming in and what's being utilized on a daily basis can be pushed out to you. But remember that information needs to come from a ERP or a MES as to what the status is, because what we do is plan and what you're doing is actual. That information can be brought for your reference as an analytic. The answer is yes.
Right. And we can also look at future utilization of, based on upcoming orders and the overall capacity, what would be the future, utilization of each of the resources would look like. So we get an insight in advance.
So to clarify what Sheetal is saying, what we were showing you was just production firm orders. But let's say you have a window in which you have to schedule planned orders, which are not yet scheduled and released. Those can be quickly brought in and analyzed and reported back into your replenishment planning system with due dates, and then released back into the system, which means it has the ability to compute what capacity is already allocated. That means that orders are fixed and I'm not going to use that capacity. Now these are the additional new orders which have come in to schedule these work orders. This is the date by which we can do it, and that is the additional capacity which will be consumed at so and so date to be able to do that. So all of that is happening behind the scenes, and it's computing as more and more orders are coming in. It's updating the tables for capacity and utilization and labor and tooling and inventory at the same time, and it's giving you that information on a weekly, daily, whatever basis you want that to come.
Right. And Anirudh, on that point, in case, say, for example, tomorrow, if some orders would get executed, there could be some machine breakdown. So tomorrow the situation might change. So Logility as a solution would automatically next day take the information, the latest information of how much inventory we are in, how much things are in work in progress, and what are the remaining orders to be executed, and it would automatically optimize and give you a latest fresh schedule, right?
So let's say, to Sheetal's point, today something has happened. The machine which was scheduled is not available for, let's say, 6 hours. You can go and make that machine unavailable for the next 6 hours, and then you can rerun your scenario and see if the work orders have been moved to an alternative routing, if it's available, a different machine which isn't running in parallel. And if not, then it will tell you that these orders are going to be delayed by this and this time, and it's going to automatically resequence all the subsequent operations and the orders which are coming in. So the linkage is, if the first step in the process cannot be executed, the remaining cannot be executed. So it's going to move out the remaining operations and move everything out. If that's the outcome which it gives you, because you don't have any other machine or you don't have any other alternative to go make it happen, then it's going to move everything in one go. So it's linked, it's connected, it's going to resequence and resort and recalculate and give you an outcome. You're right, Cheetah. It will.
Yeah. So it not only looks at your existing resources, but it also looks at, hey, if this resource is fully utilized, then let's look at some alternate resource. So we can, have those modeling in place for alternate resources. And I'm assuming the same would be available for alternate material as well for for a particular raw material. If the raw material A is not available, then it would look at the
So if you define the BOM, and within the BOM, if you have BOM number 1, which takes into account one item, and BOM number 2, which takes into account the other item, then it's going to take that and model that in the application and say, if this is not available, but this is the new BOM, and you can take the new BOM, and you can, because that material is available, then you can resequence that. Yes, it can do that as well.
Imagine doing all of this in Excel or not being able to model it in an advanced system. How much time and effort would go in terms of optimizing the overall plan, and Logility with a click of button is able to do and give us the updated schedule and the updated result. All we have to do is just look at where exactly there are challenges, exceptions, and just manage them. And Logility would have all those scenarios created. So absolutely, fabulous way of working and using the supply chain team so that they can do a lot more analysis.
Sheetal. Um, Obviously more productive, obviously more sensitized to the needs of the manufacturing plants, because often what happens is between sales planning, the important piece of making sure that manufacturing, which actually makes the product, is given the right due importance, and the tools to be able to solve the problems is very critical to a business. So if you are a manufacturing oriented business, then you need to think about using something like this to be able to improve your responsiveness to your customers and also your collaboration with your internal stakeholders. Absolutely critical.
Perfect. Thank you. We are sharp on time. We'll be closing the session now. Just to let the participants know that this webinar is recorded, so you would soon get a recorded video of this session, which you can pass along to your team as well, in case or to the right people, in case you are or you want to just revisit this webinar again. So you would get the recording of this webinar. In case you have further questions, do reach out to us you can reach out to me at sheetal@anamine.com, or we'll send across the details in the email. If you are keen to look at the demo of Logility for your business processes, we would be happy to get on a call, understand your requirement, and showcase our solution based on your requirements and needs. We would be happy to engage further. So details of that will follow shortly after the session today. But I thank you all for joining in today's webinar. Thank you for your time. Thank you, Anirudh, for walking us through the Logility
Usually.
platform and solution. And have a good day and good
Thank you.
evening. Thank you.
Thank you, everyone. Thanks a lot. Have a good day. Thank you.